All right, my friends, we are going to continue with our conversation about rational functions, and where we're moving. In the prior lesson, we graphed rational functions that were in HK4, and where we're going to move to is graphing rational functions in a different form. And to do that, there's some embedded skills within that, and one of them is that we're going to have to be able to simplify and work with rational expressions. And within that, you're going to have to do a lot of effing it up. That's right, you're going to have to factor it up, baby. All right, so what this lesson is going to center around is one, it's going to do a little bit of review on factoring, but then it's also going to get into how do we use factoring to simplify our rational expressions. All right, and then that will lead us into our conversation about working with and graphing rational functions that are not in HK form. So there's kind of the overview of where we're going today. So to get you thinking, all right, we're going to do 3 factoring problems here as an opener. So why don't you go ahead and pause the video, take 4 or 5 minutes to go through those, factor those problems, flip the video back on, and we'll see how you did. All right, so I'm going to go through these 3 problems. I'm going to go through them fairly quickly. So if I am, just remember, you can always pause the video, write some things down, turn it back on, and listen to the conversation. Play it back if you need to. Now, I'm going to factor everything with an area model. All right, and so when we do that, all right, it's going to look something like this. All right, for those of you that are unfamiliar with the area model. All right, our A term always goes in the upper left-hand corner. All right, our C term always goes in the lower right-hand corner here. All right, and then what we're going to work to do is that we're working to find this pattern. And what we've talked about when we've talked about factoring is that we're going to do A times C. So in this case, that's 1 times negative 24. So we have to find 2 numbers that multiply to be A times C. But then they have to also add, all right, to be our B term, whatever that B term. So in this case, it has to add to be 10x. All right, so in this particular case, it would be 12, right, times negative 2, that's negative 24, and then 12x plus negative 2x gives us 10x. All right, and then you just drop these 2 terms into either of these open boxes here, and it doesn't matter which order you put them into. So I'm going to put the positive 12x here. I'm going to put the negative 2x here. And then what we're doing now is we're going to look at each column and then each row, and we're going to factor out a GCF. So when I look at this first column here, my GCF is an x. All right, when I look at my second column here, my GCF is a positive 12. All right, when I go to my first row here, my GCF is x. Now notice on my second row here, 2 is a GCF, but also they're both negative. And anytime both terms are negative, I want to factor that out as well. So I'm going to factor out that negative 2. All right, and then these 2 guys right here are my factors. So this factors into x plus 12 times x minus 2. All right, and so that's our factoring there. Now, you may not factor with the area model, and that's totally fine. So as long as you have a good method for factoring, all right, keep doing what you're doing. But, all right, the area model is very concrete. All right, it gives you a blueprint to work through every time. Now, it might get a little bit cumbersome depending on how large some of these numbers are over here and how many different choices for factors we might have. But there is a finite amount of choices, and you will eventually get there. All right, so now let's move on to our second one here. So once again, I'm going to do our area model here. All right, and this is where it does get a little bit challenging. Once again, the A term is in the upper left-hand corner. The C term is in this lower box here. Okay. Now, once again, I'm going to do A times C. So I'm going to do 12 times 15. All right, and that's 180. So I've got to find factors of 180 that add to be our B term. So in this case, they have to add to be negative 29x. So now a couple of things. Now notice we have a positive number here. So that means it's either going to be a positive times a positive or a negative times a negative. And then what we know is that it's got to be a negative times a negative because I have to add to be a negative number down here. So knowing your multiplication and then seeing what that B term is will help you with some of the signs. All right, now in this case, if I do negative 20 times negative 9, I get positive 180. And then if I do negative 20x plus negative 9x, I get negative 29x. All right, so there are my patterns here that I want to drop in. I'm going to drop the negative 20x in here. I'm going to drop that negative 9x in here. And then once again, we're going to go column to column, row to row, and we're looking for those GCFs. All right, in my first column, my GCF is 3x. All right, now in my second column, my GCF is a 5. Now, here's also where there's a little bit of being familiar with the process, is that I know I have to get a positive 5 here, or positive 15 here, but a negative 20 here. All right, so now when I go through and look at my GCF here, can we see that it's going to be a 4x like that? Okay, and now once again, now I got to think about signs. So I factor out a positive 4x here, but I got to get a negative 20x here. So I need to make this 5 negative, so that when I do 4x times negative 5x, I get that negative 20x there. When I do 4x times 3x, I get that positive 12x squared there. So you have to kind of confirm those signs sometimes just to make sure you're factoring out, all right, whether that GCF is a positive or a negative. All right, so now when I move to my second row here, my GCF I can definitely see, all right, is a 3. Now, once again, I got to think about, okay, what sign do I want here? So notice this is a positive 3x, so 3 times 3x would give me a negative 9x. So I need to make this a negative. And then I get negative 3 times 3x is negative 9x, and then that works out really well because then negative 3 times negative 5 is that positive 15 that we want. And so now there are my two factors, okay? 4x minus 3 here times 3x minus 5, like so. All right? And so hopefully some of this is coming back to you. All right, now real quick here. All right, when I do the area model on this problem, this one's a little bit easier in some ways because notice there is no b term. All right, so that means I have to add to be 0x. So I have to do a times c, which is negative 4, and then notice I have to add to get 0x. Now, when this happens, what this means is we're dealing with perfect squares. So the only way to add to be 0x is I have to have opposite numbers. So in this case, positive 2 and negative 2. Okay, so this is a really big hint that when we're doing this, it's going to be what we call the difference of two squares. So notice 2 times negative 2 is negative 4, and then 2x, all right, minus 2x is 0x. And then I could just drop those guys in, 2x, negative 2x. My GCF here is x. All right, my GCF here is 2. My GCF here in the first row is x, and then I get a negative 2 there. And so that gives me x minus 2 times x plus 2. All right, so there's your real quick review on factoring. Okay, so now why are we doing this? All right, the idea is that now we're going to look at rational expressions. And a rational expression is going to have a polynomial over a polynomial. All right, and what we want to do is be able to look at those polynomials in lowest terms in the same way we look at fractions in lowest terms. So when we look at 20 over 25, right, we can look at that as 4 times 5 over 5 times 5. And then the way we reduce is we say what is common to the numerator and the denominator. So 5 divided by 5 is 1, and that leaves me 4/5. All right, so we find that common factor that is divisible in the numerator and the denominator. Well, that is the case as well when we're dealing with rational expressions that contain polynomials. All right, we want to get to the same step right here. Well, it's not as obvious as when working with numbers, and that's where the factoring comes in. So in order to reduce a rational expression, we have to factor that numerator completely, factor the denominator completely, so we can see what is common to both. So notice these are two problems that we have up here. So we know from our work in the opener that x squared plus 10x minus 24, that factors into x plus 12 times x minus 2. And we know x squared minus 4 factors into x plus 2 times x minus 2. And once this is factored, notice now we can see what is common to the numerator and the denominator. We can see that x minus 2 is common to the numerator and denominator in the same way the 5 was here. And so notice those would divide to be 1, which would leave us x plus 12 over x plus 2. All right, so now, all right, the other difference is, notice, when we're dealing with numbers, our denominator can't be 0 because we always have, all right, some type of integer in the denominator. That is not so when we deal with rational expressions. So we have to think about domain issues. And when we're dealing with rational expressions, the domain issue that takes precedent is, does the domain equal to, or excuse me, does the denominator equal to 0? So what we want to do is, before we reduce everything, we want to think about what makes my denominator 0. And so notice here, we couldn't have x be negative 2 because that would make x 0. For this factor, x couldn't be 2 because it would make it 0. So what this tells us is our working domain before we do anything would be all real numbers except x can equal to 2 or negative 2. All right, so before we ever start the problem, we have to throw those values out. Okay, and we'll emphasize that a little bit more as we go through the video. All right, so now, so a rational function, like I said, is a polynomial over a polynomial. And notice right here, whatever polynomial in the denominator can equal to 0 because that gives us an undefined value. All right, so what are our steps, for simplifying rational expressions? Well, we want to factor the numerator. All right, and then we want to factor the denominator. There we go. Maybe I can spell that right. All right, denominator. I left out an I in there. There we go. All right. Now, once we have the numerator and the denominator factored, now we want to consider our working domain. All right, and that's exactly what we did up here, right? So we want to throw those values out that we can't use. And then step 4 is that we want to simplify and reduce. All right, so those are the 4 steps that we want to go through, each and every time we're dealing with a rational expression. All right, so if you need to pause the video and write all those down, do so. All right, if you're ready to go, let's go ahead and flip over and let's go through a few examples together. All right, and so you can see kind of how this works. All right, so now, if we look at problem 1, all right, notice it's already factored for us. All right, so we basically get to skip steps 1 and 2 and go right to step 3, which is, okay, let's think about our working domain. All right, now, in our working domain, we want to look at each factor, all right, and set those equal to 0. So notice 2x minus 10, that can't be 0. All right, x plus 1, that can't be 0, which means that 2x can't be 10, which means x can't be 5. And then over here, this means x cannot be negative 1. All right, so the 2 values we have to throw out right away, right, is our domain is all real numbers except x can't equal to 5 or negative 1. So we can use everything but those 2, values. Now we go back and look at it. What does the numerator and the denominator have in common? X plus 1, correct? So we know that divides out to be 1. So then our simplified expression is x minus 8 over 2x minus 10. All right, and you can see this is why we want to do the domain before we reduce, because if I do that after, sometimes you don't go back. And we remember it's the beginning of the problem that sets the domain, not the end. All right, so you can't see that in the reduced version that you can't use negative 1. All right, so now let's move to number 2. Now, just to make it a little bit easier, all right, we have 2 factoring problems here, because notice it's not factored, right? So I need to factor 2x squared plus x minus 6, and I need to factor x squared minus 4. All right, I'm just doing this on a blank sheet of paper just to make it a little bit bigger and easier for you guys to see. So now when I do the first one here, I'm going to do my area model. All right, my A term goes in the upper left-hand corner, C term in the lower right-hand corner. Now I'm going to multiply A times C, so 2 times negative 6 is negative 12. So I'm going to find 2 factors of negative 12 that add to be my B term, which is 1x. All right, I'll give you, if you want to pause the video and think about that, all right, and try to figure that out, that's great. But what I'm going to say is that it's going to be 4 times negative 3. That's negative 12. And then what I know is 4x plus negative 3x is that positive 1x. So I can drop that 4x in here. I'm going to drop that negative 3x in here. And then we're going to go through, right, and look for our GCFs. All right, so in my first column, my GCF is an x. In my second column, it's a positive 2. All right, in my first row, notice my GCF is 2x. And notice in my second row, it is negative 3. Both terms are negative, so I can take out that negative 3. All right, so now what I can see, all right, is that my numerator factors into 2x minus 3 times x plus 2. Now, I already know the factors of x squared minus 4 because we did that in our opener, so I'm just going to cheat the process a little bit here just to save a little bit of time. And we know that that factors into x minus 2 times x plus 2, like so. All right, so there's steps 1 and 2, right? Factor numerator, factor the denominator completely. Now we want to look at that working domain, right? What can we throw out, right? So what we know is x minus 2 can't be 0, and x plus 2 can't be 0, which means x cannot be 2, and x cannot be negative 2. So our domain then is all real numbers, right, except x can't equal to 2 or negative 2. Now I can go back and simplify, and notice x plus 2 divided by x plus 2 is 1, which means our simplified version here is 2x minus 3 over x minus 2. All right, let's do one more together here. All right, and so let's go to, all right, and I'm going to have 6x squared minus 4x minus 16. I need to factor that guy. I need to factor 5x squared minus x minus 18. All right, now notice the other thing before I start factoring, sometimes it's really effective, all right, to factor out a GCF. And so notice in my numerator here, I can factor out a 2 before I begin the process. And that's going to make those combinations when we do our area model fewer for us. All right, so anytime you can factor out a GCF before you begin, it's just going to make your life easier. And so notice now, when I do my area model, all right, my A term is going to be 3x squared. My C term is negative 8. And notice now when I multiply A times C, I'm going to do 3 times negative 8, which is negative 24. And that's much better than 6 times negative 16. And then I have to add to be this B term right here. So I have to find two things that add to be negative, all right, 2x. All right, now once again, if you want to pause it and go through this on your own, you can. But I'm going to jump right in and say this is going to be negative 6 times positive 4. That's negative 24. And then negative 6x plus, all right, 4x would give me negative 2x. All right, I'm going to drop that negative 6x in here. I'm going to drop that 4x in here. All right, our GCF in that first column is just an x. The GCF in our second column would be negative 2. All right, our GCF in our first row here would be 3x. And then our GCF in the second row would be 4. All right, so now when I think about factoring my numerator, I have to take all the factors, right? That includes this 2. All right, so now what I know is my numerator would be 2 times x minus 2 times 3x plus 4. So when we say factor, that includes the constants. Now, it's not going to really affect much with what we're doing today, but when we start graphing, if you lose that constant, it could have a big effect on what your graph looks like. All right, and then real quickly here, let's go through and factor our denominator. All right. Okay, so I'm going to drop that A term in the upper left, C term in the lower right. All right, now I'm going to do 5 times negative 18. All right, so that's going to be negative 90. All right, and then I'm going to have to find two things that add to be negative 1x. All right, so now when we start thinking about what those are, okay, all right, I'll give you guys a minute to think about that, all right, and see what you come up with. All right, what'd you get? Okay, hopefully you got negative 10 times positive 9 is negative 90, and then negative 10x plus 9x is negative 1x. All right, so once again, I'm just going to drop that negative 10x in here, that positive 9x in here. All right, our GCF in that first column is just an x. In our second column, it's going to be negative 2. All right, in our first row, we're going to get 5x. And then in our second row, we're going to get positive 9. So now, when I come back over here, I can see that I factor this into x minus 2 times 5x plus 9. All right. So there's our factoring. So now what we want to do is look at that domain. So we know x minus 2 can't be 0, which means x can't be 2. 5x plus 9 can't be 0, so that means 5x can't be negative 9, which means x can't be negative 9/5. So then our working domain would be all real numbers except x can't equal to 2 or negative 9/5. And then our last step is just to simplify. All right, so x minus 2 divided by x minus 2 is 1, which means we're left with 2 times 3x plus 4 over 5x plus 9. All right, my friends, so there's your introduction to reducing and simplifying rational expressions. All right, be sure to do your video check-in, and I will see you guys next time.